Welcome to Max and Mojo Community Meeting. As you might notice, we just changed the name. It's no longer just Mojo, it's Max plus Mojo, and it will be abundantly clearer why once you listen to Zach and Tim's talk, which is the third talk today. But we are going to start with talk from Gabriel on small buffer and small string optimization.
Thanks, Tatiana. I'm going to share my screen.
Yes, please do. Wonderful.
Hopefully everyone sees correctly. Yeah, so I'm going to give you a bit of an update on the small string optimization and small buffer optimization work on the standard library. To be clear, the pull requests are already made, the CI is green, and the maintainers are generally in favor. It's just update about how we're doing it and the lesson learned. So quickly about me, I've worked a lot on open source before, especially in the Python world. And I'm super excited about Mojo and everything it brings to the table. And so yeah, right now I'm working a lot on the Mojo standard library. It's pretty fun. Why we want small string optimization? What is small string optimization? First and foremost, you have to know that the more information you have about your data, the better you can optimize your code. That is just a general statement in software. A good example would be a UTF because, for example, the Latin characters are really common and they take only 1 byte. And characters like, for example, the Greek characters, they take more bytes. I don't remember 2 or 4, but something like this. And we know that in the wild, a lot of strings are really small. So, for example, the empty string, that's the most common string. But then you have like file path, JSON keys, dictionary keys, personal info, names, addresses, LM tokens. They're all really small strings, like under 20 characters. And what is SSO? It's a trade-off between time and space. It's like you increase the amount of memory you use, but you save computation and time. And nearly all major languages implement SSO in one form or another. So it's like generally something really safe to do. So let's jump into it. So for people who don't know small string optimization, we must first start about what is a string and how does it work. So here I take the example of Mojo string. So you have an unsafe pointer that points to a buffer on the heap. For simplicity, we're going to say that each character is 1 byte. And then you have the size of the string, which is the number of characters you have on the string. And then you have the capacity, which is the amount of letters that you can add to your buffer before having to reallocate a new buffer. So it seems really simple, and you might want to ask, why isn't it optimal? It seems really simple. The problem is that as soon as you hit the heap, you have to do an alloc. An alloc is a system call. You have to ask your operating system for memory, and that's really expensive. And that is being seen especially in small strings because it's really expensive to require memory just for a few bytes. So how do we fix that? So I'm going to show you the simplest way to fix this. It's you add a pre-allocated buffer here. As you can see, just next to the pointer, the size and the capacity. So this is on the stack. This is not on the heap. And it has pretty much no cost to allocate this small buffer. It has to be a fixed size, known at compile time. So here, for example, we give an example with a size of 8 bytes. And so if you have less than 8 characters, you can use this small buffer that is pre-allocated. And then you have your pointer that is going to point to your data, your small buffer here. So that's how you find your data, right? And as soon as you add too many letters and the number of letters goes above the capacity of your small buffer, you start to copy of the letters into the heap, into an allocated buffer where you have to do a syscall and everything. So why is it faster? So you have 2 reasons why this is faster. The first reason is that you don't do alloc, which means no syscall, no asking the operating system for memory. The memory is pre-allocated for the small strings, and you don't pay this cost. And afterwards, the second reason is that it's really cache friendly. Most CPU have line caches of 64 bytes, something like this, which means that, for example, if you try to access the pointer, then it's going to try to load all the 64 bytes that are next to it, which means that it's going to load your small buffer too, which means that the access to those letters is going to be really fast if your string is small and fits into the small buffer. So next, we have small buffer optimization. Like we talked about small string optimization. Now, small buffer optimization, what is different? As you can see, the two slides are really similar. You can see. The only difference is that then you don't work with letters, right? You work with an arbitrary type, that is type T. And instead of storing bytes, you store arbitrary structs, right? And it's the same principle as instead of working with the list of bytes and adding them to the heap, then you have a pre-allocated buffer where you can put your arbitrary elements on this pre-allocated buffer. And then as long as it's not too big, you don't need to call alloc. And you have the same benefit about cache lines if your data is not too big too. So yeah, that's pretty simple. So it's like a prequel. Like now, right now, you've learned that small string optimization is just small buffer optimization with this t equals uint8. That's it. If t is a letter, is a byte, then you get small string optimization. So how does it look in Mojo? In Mojo, it's really simple. You make use of parameters, especially struct parameters. It's really nice. So basically you have a list before, you had a list before, and now you have a list. And on top of specifying which type you work with, you specify your small buffer size, right? And you specify the size you want. By default is 0, meaning no small buffer optimization. And as soon as it's above 0, then you have allocated an inline array of uninitialized data of size, the given size. And that gives us really easily small buffer optimization. For small string optimization, it's pretty trivial too. Before we had a list of unsigned 8-bit integers. Now we have a list of unsigned 8-bit integers with a small buffer size of 16, for example. It can be any other number. Now about the performance. I know that everyone likes bar charts about performance, especially on modular. So yes, here is one. So first of all, why is there 3 different bars, right? I can explain. I've got an excuse for that. I can explain. So what I did is that I implemented short string optimization first. And then I noticed that in one of my benchmarks, things got slower, right? So I dig into it. I used perf and got the timings and the assembly code. And looking at the assembly code, I noticed that when reallocating, which means like you grow over the size of the buffer and you allocate a new one, then you have to copy all the data. We were copying 1 byte by 1 byte. This was a specific instruction in assembly. And this is really slow. Like you should never do that, never. Everyone nowadays have SIMD on their CPUs, and SIMDs allow you to load a bunch of bytes at once and to copy them at once too. And for this, there is something called memcopy, which does exactly this. And it copies in the standard library, the memcopy copies 32 bytes by 32 bytes. And if we do this, instead of just copying byte by byte, we get actually huge speedups, way bigger speedups than if you do short string optimization. And I can already hear changes curve telling me like, dude, you should always profile before trying to optimize. And here we tried to first optimize with short string optimization and profile after, which was bad. But now you can see that we found actually 2 different optimizations that are independent. It's like the memcopy and the short string optimization. We can have both. It's just that if we profiled before, we would have noticed that one was easier to do than the other. So yeah. So things that Mojo made easy. So now it's peak bad time. Don't let it go to your head because just afterwards there are things that Mojo made hard. So don't get too excited too. So writing the implementation was really easy. Struct parameters are trivial to work with. The language enforce correctness, that was really easy to get it working too. It's really readable. It compiles really fast. The standard library is super clean. That helps a lot. There are not too many use of private attributes and things like this. And it's also super easy to test because we have parameter 4 now. So for example, when you get all the unit tests for the lists, and then you do parameter 4 on the small buffer size. And so you can test for many buffer sizes, many different buffer sizes. And that's how you can be pretty sure that your small buffer optimization works. So now, things that Mojo could improve, right? Let's get into it. When you compile the standard library yourself as an external contributor, you don't have access to the benchmark module. That makes things hard because you have to write all the benchmarking code yourself. then we get a lot of compile bugs. The standard library team helped a lot with this, but the amount of workaround that we have to find is mind-boggling. The functions missing when making a flame graph with perf, so that's a bit annoying. I suspect that's because of inlining, but it's not the only reason, because you can see the list of functions that are in the executable at the end. So you can see that the whole stack is not present. There are functions missing in the stack. It's like unknown function. It's impossible to have truly reproducible benchmarks because we can't pin the nightly Mojo version. We can only do Mojo, like modular update nightly Mojo. We cannot say which version we want, so it's quite difficult to pin a version and to iterate on this version. And since the standard library team has other things to do, so they cannot merge the pull request super fast. And because of this, and because of the fact that we can pin the nightly version, then as soon as we upgrade my mistake, we have to upgrade all our pull requests to the latest version. Also, there is a difference in performance between Mojo Run and Mojo Build. I don't know if it's common in other languages. It's just coming from Python. That's a bit surprising. I would expect Mojo Run to compile something and then just run it, but it's not the case. It's faster to do Mojo Build. And then using add parameter 4 is really slow to compile. So the unit tests were like much slower to run, especially to compile, not to run, but to compile. But not sure we can do anything about it. It's just compiling the same function a bunch of times. So yeah, that's it. I hope you've learned something useful, and yeah, please ask if you have any questions.
Okay, we have time for maybe one question. Darin.
Oh, I'll ask a question. I love how you're using a parameter on list instead of inventing an entirely new data type for this. That makes me so happy. With string, do we want optional inline elements that add to the size, or do you want to steal from the existing fields? Right, because strings are pretty common. Using 3 words has a lot of fluff.
I see what you mean.
And I think that the C++ strings typically will use like one byte of the capacity or something, or a flag on that to say, hey, I'm going to actually use the 8 words as the data. I'm curious if you thought about that.
Yeah. I definitely watched how they do small string optimization at Facebook, so I have a pretty good reference. So the reason we do it this way is because the standard library changes really fast and breaks stuff all the time, and we wanted to start with something easy.
That makes tons of sense. It would be something to look into, because at some point we'll care about size of string itself as well, and you'll want small string optimization without having to opt into it. But this is awesome. I love your work.
Yeah. So for example, here, for people who don't necessarily understand, here, if we store data on the buffer, for example, the capacity, you don't need it because the capacity at compile time, it's the size of the buffer, for example. So you can use this space in memory to put some other thing. But yeah, there are a bunch of tricks we can do. It's just, we'll do it in the future.
Yeah, makes tons of sense. Cool.
Okay. Thank you, Gabriel, so much. This was actually incredibly insightful. Our next talk is by Soren on DuckDB bindings.
Thanks. All right. Can you see my screen?
Yes.
All right, perfect. So yeah, hi everyone. I'm Sören. I'm pretty new to Mojo, and so I'm very grateful for the opportunity to show my very first Mojo project here, which is a Mojo client for DuckDB. So for those of you who don't know DuckDB yet, let me just give you a very quick overview. So DuckDB pitches itself as a fast in-process analytical database. So it's a full-featured mess, has all the things you'd expect from a database, like full SQL support, transactions, persistence, and so on. It's an embedded database like SQLite, so there's no server component, and we have direct memory access from the host process. Unlike SQLite, it's really optimized for analytical workloads. For instance, for aggregations over entire tables, touching almost all the data, or joins between very large tables. And to support these workloads efficiently, it has a columnar vectorized query execution engine and a lot of optimizations and algorithms to speed up these kinds of workloads. And another thing that makes DuckDB really powerful is the feature set it provides beyond the core database things, right? Things that make your life easier, like reading from CSV very fast, robust, or writing Parquet files that are possibly remote in some bucket, or just directly reading from Hugging Face datasets, connecting to Postgres and so on. So it's a really nice tool. And it's written in C, already has it has CLI and already a lot of client APIs for quite a bunch of languages. And it has an especially good integration with the whole Python data ecosystem, like pandas and PyArrow can directly read from data frames and so on. Given Mojo's Python, why not just use the Python bindings, the Python client? And I guess it's a totally reasonable choice to use that, but I think there are also some good reasons to actually have a native Mojo client. And so I created one. So one thing is, of course, the integration. So we have could have a much better integration with the language, with the type system, and native Mojo data structures, of course, performance, memory, and for some use cases, it also makes sense to have no dependency on Python. And last but not least, of course, my personal reason is that it's been a great opportunity to actually learn Mojo. Let me quickly switch over to show you a demo of the bindings to see a little bit more practical stuff. So I have a notebook here, and once I've imported the DuckDB can connect to a DB library, so I can connect to an in-memory database, but of course also to some persistent database on disk. So let me just use here the in-memory database here. And once we have this, we can actually run SQL queries. So here we create a table, DuckDB table, train services from Parquet file, which is in some bucket. So that will take a few seconds to download it. And once we have that, we can actually run queries, like getting the top 3 busiest train stations here, and then fetch the results. So let's do this. And first of all, what we do is we print the columns of our result. So we have station name and num services, which is a string, an int64. And now it gets interesting because Mojo is typed. So we want to extract these things into native Mojo values with types. And what we can do is, if we know the types, we can actually call this get function here on result with an expected type, so string and int64 here. And with dependent typing, we actually get the native value with the right type out. Here we just print it. It doesn't really matter, but in other cases, when we want to work with these values, it's quite useful. So what we can also do is just use some DuckDB features, a query, and write it to some CSV file, which we can check here. And we also support nested types. So DuckDB has nested types like lists and maps and so on, and they can be arbitrarily nested. So this is also interesting in terms of when we want to extract them into static type values. So here we have a single row with a list of strings, and we can fetch that. And we can see that we have this column, which is a list of string. And so this is just a print helper here. And what we can do now is again use our get function, our get method on the result. And this time we say, okay, we know the type, it is a list of string. And because the dependent typing, we will get the right result, like a list of string. There's also optionals here. That's just because everything is nullable. But we can see that this works. Like depending on the expected type we put in here, we get the right native Mojo type. And so let's just try with a different type, wrong type, and then we get a nice runtime exception because, of course, the database types the runtime type could differ. So if you get it wrong, you don't want to have garbage, you want something like an exception. Yeah, and that's it for the
That is
demo.
really cool.
Thanks. So let's just quickly have a quick look at the implementation. So one thing is of course, we need the bindings. DuckDB provides low-level C bindings, and right now we don't have any binding generator. So this is actually manually translated with a bit of help of machine learning models for auto-completion. But these are very low level, of course. So this would be just writing C in Mojo, and of course we want to have something more high level. So we wrap this API in for instance, a connection struct here, which takes care of actually memory management and converting things into Mojo types to have a much nicer syntax and safer things. And this typed result I just showed you, this actually, I think, a little bit more interesting, but also something I've struggled most with. So currently this is implemented in terms of wrapper types. So we have this DuckDB value trait with an init method and then implementations for all the supported types. And here's the actual logic to build these values, to convert these values into native Mojo types. For string, actually, what's quite funny is that we have these small string optimization in DuckDB. Yeah. But these wrapper types are not enough. So we want the API to be easy to use. So we have this typed column here, which actually has as parameters the target type and this builder type, which are these values. And so we know how to build values of this type. And then we have, and also the runtime type for checking. And then we have aliases for all the primitive types and this list function that uses some type magic. So it's a really cool type system in Mojo to actually make this possible to do these, to build these conversions for nested lists of any depth. And finally, once we have this, we can just use these types in our get function, do the runtime type check, and then let the builder do all the magic for conversion. And right now it's a bit ugly. We still have to do some bit casting. So I hope in the future this will be easier. So what's next? Of course, we want to support all DuckDB types, improve the API as the language evolves. Especially, I think there are interesting things for these typed outputs, like not only for a single column, but really turn a result into a type result with all the expected types. But I think we need a little bit more stuff here in Mojo with abstracting over variadic types and maybe also generic traits and things like this. So if you're interested, yeah, you can go to the GitHub or just ask in Discord. Okay, that's it from my side. If there's still time for questions.
Yeah, we'll have time for one or two questions.
Yeah, super awesome project. Just that small string optimization you were doing. It looks like you were treating like the pointer, the size, and the capacity as like actual data if it's less than 12 characters. Is that what's going on there?
Yeah, but that's in DuckDB, right? So what I'm doing is just the conversion. They already do this, like depending on the size of the string.
Okay, right. Yeah, awesome project. Like really creative use of the type system and level documentation and everything. Really cool.
Super cool. Yeah.
Thanks.
Thank you, Søren, for the presentation. Okay, we'll now go to Zach and Tim to talk about Max and Mojo package. And what does Max plus Mojo mean? Zach.
Let's do it. Do you want to present, Zach? All right, great. So this presentation, there's a few things in this. We'll try to note all your questions down. I'm sure everyone's going to have a whole heap of questions. But what we wanted to take you through was a few things. One, the rationale around some of our packaging strategy. And then after this, there'll be a bit of a talk about the license. I know there's been a bunch of questions in the Discord on the license. And so we'll try to jump into those a little bit as well. Always love to start with what are we building and why? I think when we started on this journey almost 2.5 years ago now, our goal is really to power all of accelerated compute. And AI is certainly part of that. But Max as a platform is actually the modular accelerated execution platform. And so our goal at a very high level is to very much power accelerated compute around the world. And so I think everything we talk about today, keep that in the back of your mind because it is a unifying story. And it's a really important one that's very true to our vision of what we're trying to achieve. So a bit of the history, I think everyone here will know this. What is the story of Mojo and Max? We first shipped Mojo back in 23 by itself. It was an individual package. You could download and install it. We rolled it out on Linux, then we rolled it out on Mac. Before that, it was only available in the cloud. And then earlier this year, we debuted Max by itself, originally at the very end of February. On the 29th of Feb, it rolled out by itself. And so obviously you could install Mojo by itself, then you could install Max by itself, and we kept those packages very separate. Predominantly so that folks in the community could have the option to install just Mojo if you wanted to use Mojo. And then for users who wanted to come along and try Max, they wanted to do that. Then we combined them. So then we said, okay, now we're going to have this story where Max has Mojo, but Mojo still exists by itself. And that's where we are today. That's the story of all the way up currently in the most stable release. Increasingly, it's gotten very difficult to keep them separate, actually. We'll walk through why. And I think this is an important part of what we're trying to explain today. And the idea that Mojo and Max being separate things has actually gotten a lot harder. Here's why. So to start with, there is a lot of confusion for new people who come to our website, go through our docs and user flows to install our product. There is a lot of confusion between, hang on, what is Mojo? What is Max? How does Max fit within Mojo? Should I be installing Mojo? Should I install Max? If I want to program with just CPUs or GPUs when they come, can I do that on the single install? Can I do that under the package? So we have very consistent feedback on confusion around what to install, and that's very much our problem. The second one is just the package size. Package size is large, and we obviously want it to be very small. And we're working very hard. There's a bunch of dependencies, and Zach can talk about this, but there is a bunch of dependencies that we're looking to reduce in the existing Max package to make it much smaller. So it'll be a streamlined experience. One thing that's very, hopefully everyone here is excited about, we are incredibly excited about, is that GPU support is coming. And for that, it is highly tied into the Max runtime and the overall orchestration components that fit within Max, not within Mojo as it stands. I think there is a story here where we just wanted things to be simpler. It is a lot simpler to explain our product very much as this overarching platform, which is Max, the Modular Accelerated Execution Platform. Mojo is part of that. A new packaging infrastructure is part of that. Our framework is part of that. And so putting it under one thing actually makes it a lot easier to explain, one. And then the other thing, which again, is something that we have to deal with on our side, but it also enables us to very much keep up ship velocity. It gets more complex trying to keep everything separate and isolated than if it's running through our CI infrastructure and build infrastructure in a single way. And then also just Mojo can be used without Max from the Max package. So the idea that you can just install Max today, you can just use Mojo by itself. You don't have to use the other components if you choose not to. And then lastly, there's this just broader point that we want to stay true to our vision, right? Mojo was always designed to be a language to support this broad vision of accelerated compute infrastructure. That is why we actually built the language in the first place. And so keeping them constantly separate is actually creating more challenges for us, but also just stepping back. It also, I think, creates some separation from our actual vision of what Max is and what we're trying to achieve with Max. As many of you, you've already seen this in some of the steps that we're beginning to move towards. We are going to start packaging Max and Mojo together. And this will then be the only option moving forward from a few weeks from now. And Zach can explain why, like how that's going to work, the mechanics of it through Magic. The reasons for this are becoming increasingly because of these 3 points. And we talk about this a little bit on our website. One is that the accelerators, particularly as we move past CPUs, they require runtime components and orchestration logic that just fall within all of the infrastructure that we're building for Max, not purely for Mojo by itself. The best way to use Mojo with GPUs will be through Max. And inside the Max framework, we have some incredible graph APIs and many other components of Max framework sit within Max. And Mojo makes Max incredible for accelerated compute programming. And of course, it doesn't just stop with GPUs. Our vision, again, if you step back and you look at accelerated compute more broadly, it's not just GPUs. There are many companies around the world that are interested in partnering with us for ASICs and other types of custom silicon. And they want to be able to use that with Max, and they want to be able to accelerate their workloads too. And so Mojo being part of that story just helps us even more. So we think this is the right thing for now. Obviously, we want feedback. This is just we're trying to do the right thing by everyone. We're trying to simplify our own infrastructure and make it easier to get this out to everyone. We're trying to really move people along these golden paths to make it faster and easier to deploy without the infrastructure and build with what we're producing. So please keep giving us feedback. We're definitely listening to it. But as it stands, we want this progressive story to really move towards max nightlies and then max stable editions that have one path for both Max and Mojo included in it. Do you want us to pause for questions, or do we want to keep going?
Suggestion, why don't you keep going? Because it's just the most common questions are like, is this bad for Mojo somehow? And
Yep.
I think the answer is no. I don't think it changes anything for Mojo, but I think that understanding the other parts of the talk would make that more clear.
Let's do it. All right, Zach, you just tell me when to go next, all right?
Yeah. So that's exactly right. Just starting off, I'm really excited to get to talk about this because we've been working on this for a bit, and I just keep checking the time because I could talk about this for hours because it's a fun topic for me. But starting off, Mojo and Max, they're in a much different place than we started out. We've had long-standing issues with the modular CI that we've been chasing for a while, but at the same time, we've had to reevaluate things given where we want to go and how to fix things. Next slide. So limitations today. So modular CI, it's this bespoke thing that we invented. It made a lot of sense for Mojo and Max, and given what we were building then and some of the limitations, a lot of that's a bit moot now. And what we ran into is we're reinventing a lot of the wheels. And part of this is that Mojo and Max don't really stand alone. You use them with Python, you use them with other tools, you use them with Python dependencies. And having this independent package manager separate from the way that you version your Python code and all of your other dependencies becomes this complex monster that we give to people that they have to now manage things separately. And so it makes the Python interop story really complicated, but that's what we're actually going after. For a lot of it, we have a lot of users that want to use Max that aren't using Mojo. We have a lot of users that are using Mojo, and it makes it complex. How do we solve all of the same problems? And we didn't really want to put too much investment into trying to just replicate everything that existed in some of these other solutions. We'd rather integrate with those solutions. And I think that's where we're going. And just a more of an aside to that, one more part of that's difficult is like, how do we support people that want to use different versions of Max with their code? You want, say you check out of your code base 12 months ago, you should be able to rebuild using the Max that was then with whatever dependencies had back then. These are all problems that we ran into that we wanted to try to solve. So people come to Max for different reasons. People want to use, we want to be flexible to a bunch of different use cases, but also be something that's easy, that gets out of your way at the same time, which makes it complicated to build a system that is this get out of my way, but also let me do everything. And Python interop is one of the problems that we ran into, but we also have people that just want to have an existing AI pipeline that they already have set up and just use Max. They want to make it part of their solution that they already have. And so that means also, how do we integrate with PyTorch and Onyx and NumPy, Jupyter? Maybe I got Julia and or Rust or something in my complicated environment that I've set up from going end to end. And so how can we work within that, but also version with it? And then more importantly, having this like consistent reproducible build. I already talked about it a second ago, but it should be trivial for, say, you working with and collaborating with other people, or somebody finds your code on GitHub to be able to run it. And I know a lot of people in the community have complained about like, how do I check out a version of Max to a specific version? And then you also have to have instructions on how to check out your Python dependencies. So how can we solve that? But also this carries over to how you deploy. It should be easy enough to take this environment and containerize it and throw it up in your production environment. So these are overarching goals. So we step back. Next slide. So solution. It reduced two different options here, or two different ways of solving this that kind of work together. One is adopting standard packaging that exists in all of our ecosystems. Right now, focusing on Max on Conda, and it turns out Conda does a lot of things that we already did similar in modular CLI inside the package. So it actually works really well. But also, how do you, more than that, because Conda is an ecosystem, provide like a first-class environment for developing with Max and Mojo? And so it came to two-part solution to this. So today we have old busted modular CLI. It's been great. We've got it to a good place, but also it's just not serving us well. So now we have Magic CLI, which is a much better solution. So Magic CLI, it's a brand new package manager. It's a virtual environment around your code. So you can think of it as like a code-centric package management solution. It manages all of your Max dependencies plus all of your Python and other dependencies. It has full Conda integration, but it also has full PyPy integration. So you can pull anything from pip or from any other package ecosystem into it. It's built on this open source project called Pixie, but we add a bunch on top of it. It's also going to be the basis for new features. But the cool part about this is that we have Magic, but we also have these industry standard packages. It is entirely optional to use Magic, but we think that it provides the best user experience and we think you'll love it. So talking about the Max Conda package a bit, we have this new channel set up. You can use any of the front ends that work with the Conda ecosystem. The package internally, it's actually made up of a bunch of internal packages, but it's an implementation detail you don't have to worry about. But that's important because that actually helps us reduce the package size. One of the things that occurs with the current tough package, the modular CLI package that we have today, is that you download things that you don't necessarily need. We have a whole version of PyTorch included in there for just in case you used a PyTorch model. We have wheels that are compiled for different versions of Python you might not be using. But what's nice is in this new system, you can just express your dependencies. We can pick up on them dynamically. So we end up shipping less. So the package size is overall smaller. Now that is separated a bit here in that in the Conda environment, you actually are isolated from your system, which is both a good thing, but it does mean that you're making up some of that space that we saved by installing separate implementations from your distro, but that does give you that reproducibility. So in the end, it's great. So using Magic, it's really simple. It's project oriented. So think of it around your code base. It works like Git. So it's aware of your current working directory. It installs a virtual environment into that current working directory. You can initialize a new project that creates a manifest in your directory. And then once you're in there, you get this virtual environment command called magic run, and you can run any command, or you can use magic shell and open a subshell. And now you're in this environment that has Mojo. It has an independent version of Python from your system, but there's version for your code. So you can say your code depends on this version of Python. You can add dependencies like PyTorch or CUDA or basically anything from the Conda ecosystem, but anything from pip. It's all accessible in your package and it's all stored in there. So all of your dependencies are managed in your appropriate project manifests. It can be a PyProject.toml if your package is, or if your project is an entirely Python project. There's also Mojo project if your code is a Mojo project. You can have sub-projects eventually. That's all coming soon. But then you also have the Pixie.toml if your environment is not code specific. It's just a set of tasks, but you still want to express dependencies. And then, as I said, you got this Magic folder that exists with your code that has your virtual environment. One thing I want to call out, this comes up, big question. You see these .environment file folders everywhere. It's actually, what's cool is in the backend, it has a global cache. So every one of these environments are getting a link to that cache. So you're not dealing with every single one of your virtual environments having a separate copy. So that's been a problem in the past with if you ever used NPM, which copies the entire environment, it's solved in this setup. But you also have this lock file concept that helps with reproducibility. Just quickly, this is what it looks like right now. These aren't set in stone. Commands may change soon, but it's super simple. You initialize your project, you get your lock file, and you get your project toml file. And this toml file is basically how you express your dependencies, but all your other package information. Eventually, this will all play into future features. But for now, you can see how the channel system works, where it pulls in our channels. It also works off CondaForge packages, which is a big ecosystem of compiled packages for different platforms. And it has all of your dependencies down at the bottom. So when you add your Python and other dependencies, they're all listed. And you can either edit this file or you can use the Magic CLI to modify this file for you. So next slide. So one big thing with this is that if you're using a stable version of Max, you no longer need to do modular auth anymore. All of that is removed now. If you're using a nightly version, that might not be true, but for stable versions right now, it is completely open, so you don't have to authenticate anywhere, which is really awesome. We hope that removes a bunch of resistance to using anything. You can try it right now. So the curl command is there. More instructions are on the Discord channel today. We're also going to update the Homebrew and Debian package to include Magic in the future, and I'll go into that when I talk about the timeline here for the rollout. So how this is all going to roll out. So Magic, the alpha version's out right now. Max 24.4 is already available as a Conda package. We're going to start releasing nightly releases of Max 24.5 next week, I believe, is our timeline for that, where you can start using 24.5 nightly releases. And then in a few weeks, approximately, we'll have 24.5 ship with both Conda, and it will be the final modular CLI release that we'll release for that with the 1.0 release of Magic. So it will be the last major release. There might be minor releases, but major release of Max that will ship on the modular CLI as part of this transition. And then next month, if you already have modular CLI with Homebrew or Debian package, the plan there is to add Magic to that same package. And then eventually that package will transition just to be Magic over time. But we'll keep the CLI in there for a while. And then in several months, we'll turn down our package hosting infra for the existing modular CLI in favor of the Conda ones. The older versions of Max are already in Conda already, so they're already there, but we're going to just turn down that infrastructure just to move on to the new one because it works so much better and you don't need auth is most of what I think I had on my speaker notes. But I just want to say thank you. It's been a big journey. We've heard a lot of feedback from the community about issues that they've ran into and gave us a moment to step back and rethink this entire implementation to hopefully make things a lot easier and a lot less friction to get started with everything. That's all I've got. Thank you.
Questions?
It's next.
Any questions to Tim or Zach? Yeah, Gabriel.
Thank you. That makes a lot of sense from a user perspective, seeing this as an outside user. I've got a question about this. So since before we had Mojo was technology and Max was a product, right? So that was before. Now that it's a lot more integrated, I'm wondering if Max is becoming more like the distinction between the two is becoming more and more an implementation detail of Mojo. Do you folks need to actually keep two distinct things? Do you need two names or can you just say there is only one thing? I think it would make it a lot simpler, but I'm not insane modular. I cannot say what are your plans or whatever.
Gabriel, you don't like saying Max, Mojo, Magic and repeating that fast? I think our answer is actually that Max is really an overarching platform, right? That's the goal. And it's going to have a lot of components. Our goal is ultimately to enable folks to use those components in any way that they want. And so I think increasingly we want Max to be this centerpiece of infrastructure. And certainly I think the way we think about it today is we want you to be able to download that. It's going to be easier for us as we build our tutorials and examples and all of this other infrastructure to have a consistent user experience to download it, try it. Even if you want to use Mojo, our suspicion is in getting started guides and tutorials, particularly as GPUs come up, that you are going to want to play with Gen AI examples and a whole bunch of stuff. That's going to end up needing Max. And so it will create a super awkward experience if we started trying to package those in different ways. And then that would actually, a lot of what Zach's just walked through here is about simplifying the user experience. And so for us, making it more complex just makes all those workflows for us right now harder. And so I think over time, there's already a lot of strong brand affinity for Mojo. I think people love Mojo in its own way. We would love that to be similar with Magic. I actually think one of the things we need to do, and we haven't made any decisions on this, but one of the challenges even today is when we refer Max framework, people don't really know what that means. And today it's a compiler and runtime components and a series of APIs. You can do things in Mojo, you can do things in Python. So I think what you'll end up seeing from us is Max is the overarching platform with many components. We have a few components today. We will continue to package those as one thing I would certainly say in the near future, that's our approach. But over time, if it doesn't make sense to do that and we can spread it out, then maybe that's on the table too. We're just going to listen as we roll out, particularly as we head toward GPUs, roll it out, see how you all react and give us feedback. And if we need to make changes, we will. Does that answer your question?
And let me just add one quick thing. Gabriel, I think you're talking about like Mojo is a technology component lots of people can use, and Max is a product that ends up being paid, right? And so I think the shift, which Tim will talk about in 1 second here, is we want people to use Max for free too.
Yeah.
So that's the key thing. We're not saying Max is paid and Mojo is free. We're saying both of these things are free. And so that's a big shift. And that's a new thing we're just pulling together over the last month or so. But Tim, maybe you should jump into your slides and explain some of that.
Yeah, sorry. I wasn't sure, Gabriel, if you were talking about product positioning or you're talking about licensing. But conveniently, unless anyone else has any other questions on packaging, we have a section on licensing too. So I can walk folks through this. Okay, so we've had a lot of questions. So what does this mean for the license? We rolled out a new website. If folks haven't seen it, please go and check it out. On the website, we certainly start to explain how we're thinking about licensing. And so what we wanted to try to do in this session, and we may go over a little bit over, hopefully you can bear with us, but is really how we think about licensing for both Max and Mojo. As we just walk through, what is Max? It's this accelerated execution platform. We want it to be all these things, easy to install, certainly for AI, end-to-end generative AI inference. Today, it's very an inference-focused product. Clearly, state-of-the-art performance, and I think we'll share this as we head towards, you've already seen our performance on CPUs. As we head towards GPUs, I think that'll be very exciting. We want to be able to improve your total cost of ownership. This is what we hear certainly from a lot of the enterprises that we speak with. That's really one of their big focuses is TCO. And of course, just things like customization and flexibility. It should be super easy to use and deploy compared to all the infrastructure that has existed over many years. And again, this idea of being able to control your data and security and scale your internal innovation. And so these are all essentially what Max will give you. But now that we're combining both Mojo and Max together, what does this mean? So I think the intent, I wanted to start with this slide on what is our intent? And I think we get this question a lot. And what we wanted to be very clear on today is we want the world to use the infrastructure we're building, right? Like there are so many people every single day coming to work, investing in this so that the whole world can use it. That is the intent of what we're trying to achieve here. We want everyone to be able to build on it, and we want everyone to be able to build on it in a confident way. We have all lived and developed technology for a long time. We know exactly how the world feels about what other companies and errors they've made. That is not what we want to achieve, and that's why we're having an open discussion. We want a highly permissive and available license. That is what we are absolutely shooting for as we approach the community and the world with the Max infrastructure. And we definitely do not want anyone to fear that we will rug pull them. That is not what we are trying to do. We are trying to develop in as an open possible way as we can. And again, even having this conversation, I think, is really meaningful so that you can all go away and then give us feedback. But one thing is we do need to make money. And I think the challenge of many companies in the past with the licensing structures that they've taken have ultimately meant that a lot of the actions that were reactive to this concept of them having to make money. The infrastructure was given away for free. Then the company actually needed to commercialize. They couldn't. And so they had to change their licensing terms. We want to be upfront about this from the very beginning. And today, the way we're positioning that is very much we need to protect what we consider to be our cloud product. And that is what the intent of the license is trying to get across. We are ideally, and you'll see this as we walk through, we are building a cloud managed service for AI. We can walk through what that means. But just stepping back, this is what we're trying to structure in the license. We want anyone to be able to build on the platform. We want anyone to be able to do anything. But for the section that we have to make money on so that we can continue to build this infrastructure for everyone, we do need to have some protection around the cloud offering. So what is Max? And maybe, Gabrielle, this gets to your point. It really is everything we just talked about, all the AI infrastructure components, all the APIs, compiler, runtime, Mojo, all of it. And we want it to be free for anyone to self-manage. You can go away, you can deploy this, you can run it yourself, you get all the benefits, including across CPUs and GPUs as we move forward. You can take it, you can build on it, and you can do that with confidence. That is very much what the intent of Max is. And that is, again, the intent of the license and the way we're trying to structure it. What is Max Enterprise? Max Enterprise is essentially what we are wrapping around Max to provide enterprises with in terms of a commercial offering. So today that's going to start with support. We have a bunch of enterprises reach out to us who are very excited about where we're headed, but they want to be able to have real support from our team in helping them managing and deploy it. But also we are building this cloud managed service product. And so the idea here is that there will be services for training and for inference of AI workloads offered to enterprises very directly to run Max. And that is really the enterprise cloud offering. The idea that you can use our infrastructure to train models, deploy models, manage the infrastructure, run inference at scale, all of those things is what we're trying to achieve with Max Enterprise. So that's the difference between the two. Now, how do we think about the license? The license is really designed, again, to go back to the intent, to enable you to build and deploy into any project that isn't competitive. That is a massive, enormous section of the world's applications, basically. Unless you are very specifically wanting to build an AI training and inference product offered to developers, you can pretty much build anything. And we want you to be able to use it internally within any organization for anything. We want you to be able to scale to any number of CPUs or GPUs that you want, and to be able to integrate into projects and distribute. All of those things is what the license is trying to capture and enable you to do. And these are some really important points because I think there's been some confusion on this in the Discord. And again, we really want to hear from you. We're trying to structure this in the right way. So don't think we aren't open to changes. But really, today you are free to develop anything, to be clear. You are free to develop anything, even if it's commercially competitive. Even if today you're sitting there and you're like, you know what, my dream has always been to build a cloud-managed AI trading and inference product. Just reach out to us and talk about it if it's your exact goal. I think that we would have to figure out how to position that. But outside of that area, you're free to develop anything you want. You're free to take it and deploy it and use all the infrastructure that we've built and go and run it. So that's the first point. And the second thing, which is really important, is this idea of legacy terms. You're free to develop anything that's not competitive today, obviously, and commercialize it. So you're absolutely, and you don't need to contact us for that. Go for it. If based on the conversation you've heard here today, you're like, amazing, I want to go and develop a brand new gaming app or whatever it will be, education, wherever. And even if in the future we went in that direction, you are still protected under the terms. You are still 100% able to grow your application or whatever it is you're building. And our goal isn't to come back and say, sorry, you can't do that now. Our goal is to say, amazing, thank you for building incredible stuff on our platform, super exciting. We want to tell your story. That is the goal of what we're trying to achieve. So those two things are really important and they matter a lot to us and to doing the right thing by everyone that uses our infrastructure. So please know that the intent of this was just to really, one, continue to refine and refactor the license. We are getting a bunch of feedback on it. We are constantly trying to position it in the right way. We're listening. Of course, we're open to changes on it. We need everyone involved. All the feedback we've already been given has been incredible to the way that we've continuing to adjust and refactor the license. And we do want everyone here, and certainly everyone who watches this video, to come and build with us. That's the goal of what we're doing. And certainly why everyone who has joined Modular and continues to pour all this time and effort into our infrastructure is to help change the world. That's what we're trying to do. So, goal of this side, check out the pricing page if you hadn't already seen it. If you have any feedback, you can just join the Discord or contact us and just at me directly if you want on anything related to licensing. There is no question you can't ask that we can't. We may not necessarily have the answer. I can't promise you I have every answer to everything, but we'll be open about what we know and open about what we don't know, and we'll certainly try to get you an answer. But that's the best way to think about it moving forward. So I'll pause there if there's questions, but hopefully that adds some clarity for folks to the way we're thinking about it. But I'll assume I know questions that folks are either thinking about it or they're like, this is great. But again, please contact us. You'll continue to see us listen and quickly. Gabriel, thank you for asking a question. Go for it.
Yeah. It's not a question. It's just a feedback. I think we're really glad that Max is becoming free because the early signals that we had is that GPU runtime was going to be on Max, and this is the earliest information we had. And at this time, Max was a product, and so we were like, so we would be able to use GPUs without paying. Right. And so that's very reassuring. Thank you a lot.
Yeah, no worries. That's our goal, right? You should be able to go and build incredible products on top of our infrastructure. And we would, and again, as you do that, please tell us you're doing that so we can tell your story because these use cases and these examples for us are huge to convincing other folks to come and to use the infrastructure and develop their applications as well. So don't be shy in sharing it. These are the stories we want to be able to tell the world too. So, but that's great. I appreciate that feedback.
Yeah. Also, just a plus one point Tim made earlier, which is we're trying to be really thoughtful about this. So many other teams have gone off and built crazy stuff and then got themselves into a weird position where they can't build a business. And so we've tried to be very deliberate about this and make sure that we can build a sustainable company because that allows us to continue to invest in the technology platform and Max and Mojo and all these different things. We want to just go completely horizontal across the world. And so we're putting a lot of energy into that. And the goal is, again, make it so come back to the earlier points. So you can feel free to go build cool stuff and you don't have to worry about us doing something mean to you. And being very clear about that, I think is very important.
Yeah, and just lastly, please don't, any other thing just to add on to that, don't feel you can't contact us and discuss stuff. If you're like, I've got this brilliant idea and I'm worried Modular is going to copy it or do something, like I assure you almost certainly, unless you are building a training and inference framework, which is very hard in its own right, we are very busy on a lot of things and very focused on that objective. And so you should feel very comfortable and confident being able to go off and build lots of incredible things on top of our platform. And again, if you have any questions, just don't hesitate to reach out.
And also the dual to that is if you want to go off and build something cool and make tons of money on top of the tech platform and go do AI training and inference, whatever, just talk to us. We're very friendly. And so we'll want to make a little bit of money on that too. Fine. But that's fine. That's how business works. And so we're very happy to work with people. And there's a lot of space in this industry to go build cool stuff that's all very complementary. I have to drop it, but
All right.
thank you all to the speakers for this. This is an amazing talk.
Yeah, thanks heaps. This
Thank
was
you,
awesome.
everybody.
Thank you.